Okay, thank you so much. Thank you. I wish to thank you, Antonia, first, and all the organizers, because they continue in this work, in this path, inviting us and trying to really build up a community. And so this is an important point of our job. I'm convinced that the collaboration among us is a value itself, and that this group can really produce some interesting work, sharing competencies and data and methods and so on. So thank you so much for inviting me again. And today the topic will be always the analysis of fetal heart rate. You know, many of you know that I'm working on CTG signals, antepartum, measured antepartum. We decided many years ago to go in this direction because the signals are more clean in respect to intrapartum, and to evaluate some differences they offer in higher quality. The integration we did, there's a problem with okay. The integration we did in these years is with artificial intelligence methods. Not only we started from the extraction of parameters feature from CTG. Right now we are working on methods that starting from this feature, that's different combination of this feature, can provide more deep classification about the state of this fetus in utero. So these first slides are quite general, and I think all of you are all of you know this content. Our interest is on the fetal monitoring, and that fetal monitoring is useful to minimize fetal risk, because it allows to evaluate early, hopefully, changes that can arrive. We concentrated on cardiotocography, we concentrated on fetal heart rate, and the extraction of methods of parameters from this signal has been derivated from the experience done in adult subjects, and connecting what happens, physiologically happens to the heart, to the developing structure of the heart and its physiological and neurological controls during the pregnancies. So the last sentence, some AI research on fetal heart rate focuses on the intrapartum, we know, but we tried to work, we decided to work in antepartum in order to to identify changes earlier in time. So you know that the fetal heart rate, why antepartum CTG? Because the fetal heart rate is characterized by different behaviors. So, in case of fetal distress, the CTG signal and the heart rate derived from it. Today, we touched the point of the CTG robustness, of the CTG reliability, of many aspects that can be negative in CTG. The positive one is very easy to be collected, and under some hypotheses, it replicates quite well the behavior of the fetal heart. So as the fetal distress is often preceded by changes in RR interval, the measurement of RR interval is very important to proceed with this early identification of possible fetal diseases. One important thing is the recognition of CTG passes through autocorrelation function algorithms, and this considers the heart signal compared to for similarity to the next one. So if this technology is properly used, the quality of the fetal heart rate can be considered quite near to the gold standard, that is the direct ECG. So under this consideration, this is the object of our work. Not only the fetal heart rate, which is in the upper part of the picture, but even the TOCO signal. The work that I will present will integrate information taken from the pipeline that I propose we propose, because I'm not alone. Many people working on this are in this room, and so thank you all. And this is the example of the signal that we consider for our analysis. Nonetheless, we consider also other sources, not only CTG, but wearable signals, and obtained through, as today some of you shown, and the fetal heart rate that can be obtained recognizing fetal events inside the ECG taken from wearable sensors. So what we started with machine learning tools applied to fetal heart rate feature. The work was organized through this pipeline, and thank you Giulio and Nicolò and some other that gave, as reported in the citation, contribution to this work. And the fetal heart rate was firstly processed, then different parameters, different features were extracted, and the feature came from the world of the linear analysis, time domain analysis, frequency domain analysis, but also nonlinear analysis. So this set of features composed the information that we decided to use, to classify the fetal pathological or physiological states, and this through machine learning approaches made possible this result. So the classification of the healthy subject in respect to UGR. This is a summary. This is a summary of what we have done. This is the definition. These are the parameters that we have used. I reported them, even if you know quite well this approach, but I'm always fond of this approach. So combining together parameters with physiological meaning can help us in the classification. So not only adding new feature in order to maximize the number or improve the amount of data of feature, but choosing the ones that are related to something that physiologically happens even during the development of the fetal life, and so connected with the heart rate signal. So the feature-based machine learning provide interesting results, but there were some positive aspects that are underlined by the smiling face in green. So feature can be reconducted to physiological mechanism, and so the explainability is implicit, because if you know that something depends on some physiological event, explainability is more easy. And the other point is the averaging that we used to calculate this feature can reduce the sensibility to noise, which is always a problem inside the signals. What is, again, what is negative are the fact that the main negative aspect, we discarded the temporal consequence, the consequentiality. So time, what happens in time is discarded by this approach. And if you think that from two cells to a baby, there are 40 weeks. The process is very fast and complex, and with a lot of events developing during this time. So averaging can remove information, and even the choice of feature can be arbitrary, or and it is not adaptive to the development in time always. So to move to other approaches, there's a point that cannot be underestimated, and it is the amount of enough data. As a community, I think this could be a goal, could be a possible development. We collected in order to overcome the problem of applying methods that require big data. We collected in years, in 10 years of work, more than 80,000 records at the Partum, CTG records, belonging to healthy and pathological subject. The data set isn't projected a priori, so it is collected during clinical activities. It is affected by this characteristics. So we collected cases as they came to the gynecology and obstetric unit in Federico II University in Naples in years. So they are all collected through Philips. I don't know if Paul Amelman is here. Okay, so we worked with your CTG and all the devices. The point is the strength is a very large amount of annotated data, and they are suitable for AI application. And data are good quality data because that data were controlled by clinicians and engineers and so on. So the quality of the data is quite high. What is negative is annotation. Annotation means that the clinician reports some notes saying which is the condition of the subject. The annotations are limited in respect to what has been assessed in the neonatal outcome. Our work is in progress through natural language processing methods in order to extract from notes more information. It's still in progress, but we have only one hospital and one device. It's not a multi-center collection, of course. Okay, but the availability of this data opened the, you are checking that, okay? Opened the possibility to apply deep learning methods, and I go a bit fast, and in order to work, in order to do this work, we applied this approach to behavioral state detection. I'm proud of this work as done in cooperation with the Columbia University Group, which is here today, and it demonstrated that collaboration is the key of our work. And behavioral states here are represented activity and quiet states, and through the deep learning, in particular supervised learning, using hidden Markov models in the first approach, and the approach provides a level of probability to be in active or quiet states, and this level of probability is quite similar to the classification made by expert clinician. We applied this approach even to wearable collected fetal heart rate overnight, and this deep neural network reaches a very good agreement with the trained gynecologists that did their evaluation without knowing the results of the network, of the net. So this approach has been also applied to UGR early detection, and I have no time to go in deep about the result, but this approach provided a good separation between healthy presumed UGR. Presumed UGR means small for gestational age, but the clinicians were not sure about disease, and verify the UGR at birth. So this is a way that can be furtherly developed to classify UGR subject. These are results that can be improved, of course. And so our work is to integrate all these approaches in a monitoring deep learning based. This is a paper that has been has been published 1 week ago, and this summarizes the pipeline based on deep learning in order to generate a classification, an early classification for UGR fetuses. Sorry, I wish to thank you. I wish to thank you all of the people, all people that participated to this research. Giulio Stede, that was in Polytechnico and now is in TU. The group from Pavia, and the physicians, and of course the Columbia University group. And once again, our collaboration is the more important result we can obtain through this working in this community. Thank you so much.
Thank you so much, Maria. It's really exciting work with applications that will come to
Sorry for the
Oh,
delay.
to support us. No, you're absolutely perfect. It takes a moment to set up anyways. Any questions? Maybe the Columbia team has any questions? Sorry, I'm just kidding.
So, thoughts, comments, questions, also from the XML visitors? I know it's a bit crowded.
I have to ask this question because you spoke about it. When will all these people here accept to share the data to work together to make a huge model?
You speak a bit louder because
I was just asking when all these brilliant people here will accept to share the data, big data set, to work together to make a big model, and what are the limitations? I understand there are many, but...
Data sharing between teams and this community.
Yeah.
Demand for data sharing. There will be session on Saturday as well.
We are working to make this data shareable because we have to respect the GDPR and so all the requirements that in Italy are worse than in Europe and so on. We are trying to make, they are completely anonymized, but it's not enough. So we have to find a way to share at least a portion in which we can work together in a federated way, and so the data remains in our PC, and all can apply their algorithm and they share the results. So there are many possible solutions to be studied and implemented, and I think this community can be a push toward this shareable knowledge. I think. Thank you.
Yeah, in your downside of feature engineering, or you pointed out there's a problem in terms of losing temporality.
Yeah.
But it's not clear to me that the deep learning approach actually addresses that. Could you comment on that?
Good question. A very simple solution is to increase the number of measurements. Yes, through wearable sensors, you can have a view, more continuous view about the development of the signals. But right now, in my opinion, from the technological point of view, we are still in an evaluation stage, not in an application, general application stage. So the point is still open, and yes, with if the collection becomes more easy to do, to be obtained, yes, we can go through time in a more continuous way, not perfectly continuous, but trying to imitate this continuity. But I don't have a solution right now.
Quick one comment
Okay, but forgive me.
So, I think the other interesting point is if you compute the RR interval directly from the ECG, you avoid the low-pass filtering that the Doppler gets.
Yeah, of
so
course.
there's a major advantage of doing that, I would think.
Yes, because of course the autocorrelation introduces a low pass. Okay, this low pass can help us in presence of noise, because sometimes noise can cover the information more than the reduction made by the low pass. We have always balanced this aspect, but you're totally right. Maybe we are evaluating through wearable system, starting from the direct ECG, the possibility to improve the data quality. Giulio is an expert on this topic. Giulio Stade is an expert on this topic, and we are trying to change the way. But right now, a general collection is possible only through CTG or similar approaches if you want to increase the number of your data. So the balance is basically this: technology and number of data available. Thank you.
From the online audience, sorry. We are also still setting up, but quick question from the online audience who may or may not hear me. Let me try to ask it closer here. I hope you can hear me online. So the question is quickly about what is the difference between this NAPAMI database and the available open source, very familiar CTU Brno database.
Okay. The main difference is available data sets are some of them are intrapartum, most of them are intrapartum, and this is antepartum, and you can follow the evolution in weeks, in gestational weeks. So it starts from the data starts from 24 week and arrive to 42. So all these these weeks are represented, and you can assess this evolution. The other point is they are all controlled, the CTG. So even some computer science student made the data set much more strong and is in structure. So it is something that you can you can ask extraction of data and all the operation that you do basically on the data set. The point is right now is not shareable, not still shareable.
So it's not even open source.
No, we are working to make it open, but right now isn't open still.
But great initiative, and Saturday we'll have a session to talk again about the data hubs, and Martin Daumer again will, and he showed earlier, so Saturday hopefully.
Yeah.
So we'll progress to next talk, and then we can discuss a bit more after. Thank you so much.
Thank you. Thank you.
Right.
Off to the next speaker.
All right, yeah.
Thank you.